So in part 2, so yesterday we covered the first 2 examples, is that right? We made it through the first 2 examples. So in part 2 of today's lesson, we're going to look at more specifically what we call anomalies. All right, so we're going to talk about what does it mean for something to be an anomaly and how that relates to equations. First of all, I want to just real quick review example 1. 15 minus 2x, you have this written down in your notes, so you're not writing this again. 15 minus 2x equals negative 7x. Before I can solve this equation, before I can start doing my steps, what do I have to do? I have to get my what on the same side? My, starts with a V, my variables on the same side of the equation. Does it matter which one I move? No. However, in this case, if I add 2x, then my numbers are on one side, my variables are on the other. So that's what we did yesterday. All right, in the second equation, what's the first thing I do? I get my variables on one side of the equation. It doesn't matter if I move them to the left or I move them to the right. In this case, I subtracted 2.5y. Why would I subtract 2.5y? Why would I want to subtract it? I mean, technically it doesn't matter, but that's going to be more favorable. Why? Very good. It's a lower value, so my variable is still going to be positive. 4.5 minus 2.5 is positive, right? Okay, so we learned that in example 1. What do you notice in example 2? What do you notice in example 2? Very good. Distributive property. Okay, so with distributive property, I just subtract 4 minus z. It makes my life really easy, right? Can I do 4 minus z? No, I can't because they're not like terms, so I have to distribute. So I would go 6 times 4, which is 24, and 6 times negative 1z, which is negative 6z. Let's jump over to the second problem here. Let's talk about a really common mistake that we see with distributive property, okay? What's negative 2 times x? Negative 2x. What's negative 2 times negative 5? Guys, this is not negative 2 minus 5. It's negative 2 times negative 5, which is 10. Positive 10, or just 10. But we know that if we say 10, that means positive 10, or plus 10. All right, so that's distributive property review. All right, distributive property is a really large part of just all the sections we're learning in chapter 1. So we're going to keep working on it today. In example 3, we need to explore what we call anomaly equations, okay? So if something is an anomaly, what does that mean? Does anybody know what it means? What that word means? Anybody have any ideas? Anybody? No? No guesses, Mason? The same? No, quite the opposite. An anomaly is something that happens that is very unique or unusual to what normally happens. Okay? So you have an expected outcome. All right? So let's connect it into an equation. We've solved enough equations to this point that we know that the answer to an equation would be a whole number, it could be a decimal, it could be a fraction. All right, but we have an anticipated answer, right? Don't know exactly what it'll be, but we have a rough idea. Well, in these equations, it's going to be something very different from our usual solution. Let's look at the first one. 3 minus 4x equals negative 7 minus 4x. All right, so in our review, we talked about what's the first thing we need to do. Before we can do our steps, what do we do first? Get the variables on the same side of the equation. Doesn't matter which side, but we need to get them on the same side. Okay, so I'm going to take negative 4x and add 4x to both sides. Okay, so go ahead and write that equation, and let's do that step. Take negative 4x and add 4x to both sides, right? Well, what happens when I add negative 4x plus 4x? It cancels. Uh-oh. Looks like the same exact thing happens to the other side. Normally, when I do this step, I get a value out of it. But in this case, because they were the exact same variable, they actually completely canceled. And all I'm left with is 3 equals negative 7. So does 3 equal negative 7? No, no solution. So in the event, again, this is not typical, this is not usual, but in the event that my variables actually completely cancel out, and what I'm left with does not equal, I have no solution. All right? Now, with the problems, especially in your quiz, your test, even your homework assignment, that typically are no solution and infinite solution, which we'll learn in a second, they're going to be hidden in the original problem. How is it hidden? What do you see there? Starts with a D. We've talked about it's hidden in the distributive property. So I cannot tell by just first looking at this equation, I can't tell that it's going to be no solution. All right, let's assume for a minute we don't know that. I need to unpack this equation. What is it? What do I mean by that? I need to distribute it. And once I distribute it, now it's going to open up and I can see that my variables are the same value. Okay, go ahead and distribute this equation. So distribute the 6 and distribute the negative 4. All right, so everyone with me, okay? 6 times 5 is? 30. 6 times negative 2v? Negative 12v. Negative 4 times 3v?
Negative 12v.
And negative 4 times 1?
Negative 4.
Negative 4. Awesome. Who got all of that right? Who got all that right? Okay, great job. All right, so now that I have it completely distributed, something is pretty obvious to me. I can see that both variables are the exact same. And when I start to do my normal steps of getting my variables on the same side, what actually ends up happening is they completely cancel out. So what is left? What's left? 30 equals negative 4, and that is not true. So it's no solution. All right, so in example 4, we're looking at infinite solutions. With infinite solutions, what does it mean for something to be infinite? What does that mean? Infinity, which is never ending, forever and ever and ever. Okay, so we know that with a Christian faith, with our faith, we believe in eternity, in heaven or hell, and you know, and that's our belief. So that's another example of infinite. All right, forever, never ending. So we'll explore what it means to have infinite solutions in just a second. All right, so they did the first part of our problem for us, so that's nice. 6x plus 4. So just rewrite that. Now we need to distribute the 4 on the other side. Oh, I see a fraction. That's kind of annoying, right? Well, is that a big deal? I can just multiply a number by a fraction. You have your calculators. I mean, if worse comes to worse, you could just do that. But when I multiply a whole number times a fraction, all right, whole number is over 1, and then I just multiply it by 3 over 2, okay? So it's really not a big deal either way. What's 4 times 3? 12. What's 12 divided by 2? 6. Okay, so that's going to be 6x. And what is 4 times positive 1? 4. So I know I'm going to see it. Listen, I can already call it. I'm even going to see it on the quiz and the test, no matter how many times we review. Don't make that mistake of adding it. 4 plus 1 is not 5. Here in this situation, it's 4 times 1 is 4. Okay? All right, so now 6x plus 4 equals 6x plus 4. The same exact expression on both sides. So let's just follow our normal steps. What do we normally do? We try to get our variables on the same side, right? Okay, so let's subtract 6x from both sides. What am I left with if I subtract 6x from both sides? Yep, 4 equals 4. So now, is it true that 4 equals 4?
Yes.
So I have infinite solutions. All right, and we can prove this. That literally there are an infinite number of solutions. Give me a number between 1 and 10. We're just going to go basic numbers. Any number. 6. Okay? What's 6 times 6, everyone? 36. 36 plus 4? 40. What's 6 times 6 over on the other side? 36 plus 4? 40. Give me another number. 7. What's 6 times 7? 42 plus 4? 46. What's 6 times 7? 42 plus 4? 46. Give me a negative number between 1 and 10. Negative 2. What's 6 times negative 2? Negative 12 plus 4? Negative 8. Okay, so negative 12 plus 4 is negative 8. So let's try that again. What's 6 times negative 2? Negative 12 plus 4? Negative 8. So it does not matter. You could literally plug in 100 numbers, and guess what's going to happen? It's going to equal every time. All right? So that's why it's infinite solution. Does that make sense? Kind of seeing it that way. That's why we call it infinite solutions. Do the second one. All right, so unpack that distributive property. All right? And we know that this is an infinite solution example. We're going to pretend, though, for a minute that we don't, and you need to show me the work. Why is it infinite solution? Your work will show that. All right, so half of 6t is? 3t. And half of negative 4? Negative 2. Equals 3t minus 2. So what happens when I subtract my 3t's thinking I'm just following my steps? What's going to happen? Negative 2 equals negative 2. Infinite solutions. Why is it infinite? Can anybody explain that to me in words? Just like real short, real quick. Elizabeth?
It can.
Why is it infinite?
It always has the same answer.
Yeah, no matter what you plug in. So it says the circles are identical. What is the area of each circle? Well, if they're identical, the area is going to be exactly the same. Would you agree? Okay, the first thing we need to refresh our memory on is what is the formula for the area of a circle. If I have to find the area, I'm going to have to know the formula. Sarah? Yes, very good. Is it coming back to you now that you heard it? Pi r squared. Did you know it, Joshua? Very good. Okay, so A equals pi r squared. That's my formula to find area. So if I need to use the radius, r is for radius. Can anybody tell me what's the radius? What is it in the grand scheme of circles? What is a radius? It's half of the diameter. So this circle right here gives me the radius value. But if I were to set up an equation, could I just make this circle equal to this circle, meaning x plus 2 equals 4x? I can't, because 4x is diameter. All right? I can't say the radius equals the diameter value. I need to find the radius of the circle that gave me only the diameter value. How would I know? If the diameter is 4x, how could I figure out what the radius is? Divide by 2. Divide by 2, just half it. Just half it. So what's half of 4x? 2x, okay? So that's what I'm going to set up in my equation. X plus 2 equals 2x. Or you could say 2x equals x plus 2. All right, I think with my other classes I might have set it up the other way. Okay? Now, this goes back to, I see variables on both sides of the equation. So which one are you going to move? Try to do it on your paper. Which one are you going to move? Are you going to subtract x or are you going to subtract 2x? All right, I know which one I would move, like for sure. I mean, make the rest of the steps a lot easier. So what did you do? What did you do? Subtract x, for sure. Okay, we want to subtract x because we want to have our numbers on one side. What's 2x minus x? 1x, or just x. Okay, so x equals 2. Oh, but that's not our answer. You guys remember the triangles that we did? We solved for x, but then we used x to actually solve the question. That's exactly what we're doing here. We found x now, but now we're going to use x to figure out what the radius actually is. Okay? So if x equals 2 and I plug it in back into my circle, they're identical, so it doesn't matter which one. What's 2 plus 2?
4.
4. So my radius is 4. How am I going to use that information? Plug it into my formula now, okay? So A equals pi, which I'm just going to use the pi button on the calculator, okay? Pi times 4 squared, okay? And A equals, all right, we can use the pi button on our calculator. I do want to show you that. Hit shift and the X10 button down there by the answer button, the X10 button. That's pi. I forgot to hit shift. Shift and then the X10 button. Show your neighbor if they're having trouble finding it. Okay. Hit pi and then multiply it by 4 squared. What does it give you? 16 pi. So the area equals 16 pi, not pi 16. 16 pi. If you were to change that to a decimal, if it were to ask you, you can hit S to D. S to D and it gives you the decimal value. 16 pi is my answer. Okay? You are going to see this on a quiz. I'm just going to tell you just right up front, you will see this on a quiz. So just want to kind of maybe asterisk example 5. Your book really likes to put these types of problems on there. So we'll review it again. But you have this on video explaining how to do it. So you might want to go back when you're studying for the quiz and just watch this example. That would be a good idea. If you understand that, that's everything you need to know for section 1.3.